Hi everyone, welcome to another video. We've talked a lot in the previous few videos of this series about some different types of graphs and their transformations. And there's obviously a lot to go through. There are a lot of different types of transformations we're going to encounter. So in this video, this is like a final summary video, just looking at some further transformations of graphs, some of the stuff that we just didn't get a chance to talk about in the previous few videos. And all we are going to be doing here is taking what we've learnt from the previous videos, just certain ideas about adding or subtracting things in our graph equations and applying what we already know from the previous videos about translations, dilations, reflections, things like that, and applying these to some of the graphs that we didn't get to look too much on transforming. Now, we're particularly looking at translations in this video, as you can probably see, particularly in this first equation here. Now, let's just get straight into it here. So we have the equation of y equals 1 over x plus 1 plus 2. Now, this is in the form of a hyperbola. Remember, our general hyperbola, the sort of easiest one, our starting point here, looks something like this, in which we have asymptotes at x equals 0 and y equals 0. Now, this is all revision, so if any of these translations and things like that are quite unfamiliar to you, please consider looking at the previous videos where we went a lot more in depth. Okay, let's look at this particular equation here and apply what we know. So first of all, we have this 2 getting added here. And we remember from the previous videos, anytime we are adding a constant at the end, this is impacting on the y, and this is going to be a vertical translation. So we're going to be moving this up or down in the vertical direction. So here we are adding, so that means that our entire graph is going to shift up, but also our asymptote is going to shift up as well. Because think about it, if these two bits here, kind of this guy and this guy, if they're approaching some particular line and getting really, really close to it but not touching it, if all of these points get translated up, so every single kind of point on this particular hyperbola is getting translated up, then naturally the line that they get really close to but never touch is also going to get shifted up 2 units. So that is our first kind of transformation here. So everything is getting shifted up 2 units. Now I'm going to draw another image down here so that we can start mapping out all the different transformations we can see. So I have my grid here, and I'm going to first draw in my first transformation, which, starting with the asymptote, my asymptote from y equals 0 is going to get shifted up to this line of y equals to 2 up here. Now let's look at another factor. We can see here that 1 is being added to the x here. So remember, this denominator here, when we looked at our original equation of a hyperbola, y equals 1 over x, we said that the value of x, that is a value that can't be 0, because we can't divide by 0. Now what this is going to do, this denominator over here, is that the vertical asymptote it's going to, the position where it ends up is the value of x that results in us dividing by 0 here. So this guy here, we're going to have a value of x that makes 0 on the denominator. So if I, for example, substituted in -1 here instead of x, if I had -1 plus 1, that's going to give me 0. So my asymptote changes from, let's get everything here, my asymptote changes from 0, x equals 0, this line here, it changes to x equals -1. Because -1, substituting in for the x, gives us a 0 in the denominator, the value that the graph can't have. So this guy here is going to be a horizontal translation. So instead of my asymptote here, it's going to get shifted one spot to the left, 1 unit to the left. So I'm going to get this asymptote, x equals to -1. So the graph is intact, it still looks like it does here. It's not getting dilated or reflected, but it's just getting shifted up 2 units and left 2 units. And remember, this works in the exact same way if we just applied what we knew about these translations before. We have this thing acting on the x, this +1. We learned before that when we have something acting on the x, it gets shifted horizontally in the opposite direction. So here I have x plus 1, so it's going to go 1 to the negative direction. And we get something different when we apply things to the y. We have a positive 2, so that's just going to add, this addition is going to shift it up. So positive direction shifts up. If this was a -2, it would shift down. So it's nothing really new from what we've been doing before. But now that we have this, we can just draw in our new hyperbola. This is going to look something like this. And we can find what these intercepts are by just substituting in x equals 0 or y equals 0 into these. So let's actually just do that quickly. We have my x-intercept when y equals 0. So that's going to be 0 equals 1 over x plus 1 plus 2. Let's actually do this down the bottom because I don't have a lot of space to work with up here. So my x-intercept, I find this by substituting in y equals 0, and let's go about solving this equation. So first we're going to subtract 2 from both sides. I get -2 here equals to 1 over x plus 1. And now I just want to solve the equation. I just want to get x on its own. So let's get it away from the denominator on the right hand side. And what I'm going to do is I'm going to multiply both sides by x plus 1. That's going to get it to the left here. So I have -2 outside of x plus 1 equals to 1, because multiplying this denominator of x plus 1 by x plus 1 cancels this out. So now we can expand the brackets. I know this is quite tedious, but because this is a new function, we need new ways of finding the intercept. So expanding this bracket, I get -2x minus 2 times +1 gives me -2. And I have a few more steps to solve this. I'm going to add 2 to both sides. This gives me -2x equals 5. Oh, whoops, sorry. This is meant to be a 1. Adding 2 to both sides gives me 3. And dividing both sides by -2 here is going to give me my x on its own. So I therefore get x, my x-intercept is -3 on 2. And that kind of checks out here because this is -1 here. So this is the x value of -3 on 2. That is my x-intercept. And finding my y-intercept, that'll be a little bit easier. My y-intercept I get when x equals to 0. So I have that y equals to 1 over 0 plus 1 plus 2. Now 0 plus 1 gives me 1. 1 divided by 1 just gives me 1. That's 1 plus 2. And that equals to 3. So, kind of checks out again. This point here is going to be 3. And just visually looking at this, we could tell roughly where these intercepts were going to be, but we can just show this by setting my other variable to equal 0 and then find the intercept from there. Okay, let's look at another example here. And if we remember from our previous videos, this is acting on the x, this is acting on the y. And since this is in the same kind of form, when we have this for, now let's note what equation this is. This is the equation of a circle, which is x squared plus y squared equals to the radius squared. So we already kind of know what the radius is, because I can write this as x minus 2 squared plus y plus 3 squared equals to 3 squared. Remember, I can write 9 as 3 to the power of 2, because 3 times 3 gives me 9. So I have a radius of 3 here, and when this is in this particular form, when it is inside the brackets, we are going to shift these across in the opposite direction. So this particular transformation here, this is a vertical, whoops, not a vertical, this is a horizontal translation, and this thing here is a vertical translation. Okay, and that means that the horizontal translation, this shifts my circle's center 2 units to the right, and this one here goes 3 units to the left. No, I lie. 3 units down, because this is a vertical translation. Okay, so that means that when we actually graph this out, I'm going to get my center of the circle goes from the origin here to the point 2 units to the right and 3 units down to -3. So this becomes my new center. And then I draw a circle with a radius of 3. So this distance here is 3 units. And I'm just going to draw that all the way around. So I get something that looks like this. I know it's badly drawn, but this is a circle with the radius of 3. Now, we can also find the x-intercept and y-intercept. We can already kind of clearly see the x-intercept is over here because it's just touching the x-axis at the coordinate of 2 in the x-axis, 2 in the x direction, and 0 in the y direction. So this coordinate here is the point 2, 0. We can also find the y-intercept here by setting x to equal 0. So my y-intercept I get when x equals to 0. So that means that substituting in x equals 0 gives me 0 minus 2 all squared, because we're substituting in 0 to here. So I have 0 minus 2 squared plus y plus 3 squared, and that equals to 9. So 0 minus 2 all squared is like saying negative 2 all squared. That gives me 4. And I have y plus 3 squared equals to 9. And I want to just strip everything away so I get left with y. So first I'm going to subtract 4 from both sides. This gives me that y plus 3 all squared gives me 5. I can take the square root of both sides now to give me y plus 3. This undoes the squaring on the left hand side and gives me the square root of 5 on the right hand side. And then finally I just want to subtract 3 from both sides. So I get my y-intercept is, or my y-intercept, sorry, I made a mistake, because when I take the square root here, I get plus or minus the square root of 5. So we can actually see there are two solutions, there are two y-intercepts. It crosses it here, and then again down here. So this is how you can sort of sense check your way through these questions too. I struggle sometimes with these too, so you will undoubtedly, like all of us, will sometimes come to these points where it looks like you've done something wrong, something's not really working out, but you can sense check it as well. You look at your diagram, you go, okay, I've forgotten this plus minus because here I would have only had one solution, but I can clearly see I have two solutions, two intercepts here. So that means that y is going to be equal to positive root 5 minus 3 or negative root 5 minus 3. Those are my two intercepts here. Okay, very last example, we're almost done. We want to look at this exponential. So, once again, we can recall what we knew from our previous videos, where we have this thing up here and this negative 3 here. Now, in this particular form, the negative 3 acts on the y. It's going to shift this down 3 units. And this x plus 2 in the power is going to shift it to the left in the opposite direction. So here, I have a shift 2 units to the left, and then here I have a shift 3 units down. Beautiful. Okay, so looking at our normal graph, I would have something like this. My exponential oops, with an intercept here. Now, remember, for this one, I had an asymptote at y equals to 0. Now, in the same way with the hyperbola, I have a 3-unit shift down. So, not only will my whole graph move down, my asymptote will also move down 3 units. So my new asymptote ends up being at y equals -3. Okay. So I'm shifting down 3 units, everything, and I'm shifting to the left 2 units. So it's a little bit tricky to work with these. So we're just going to draw something roughly and just put in a point of scale. So also we want to find a point of scale, we want to find a y-intercept as well. Now before we had a y-intercept of 1, but now our graph has been shifted down. So going from this up here, it gets shifted down 3 units. So I get something looking like this, where my y-intercept goes from 1 down to -2, and everything gets shifted along 2 units to the left. So this particular point here, that's getting shifted 2 units to the left. So everything here is gonna go left. So I have this thing happening here, and I know this is badly drawn here, I'll tidy it up later, but this point here, from up the top, it has gone 3 units down, 2 units to the left. So I get a coordinate here of -2, -2. And I just want to find my y-intercept as well, just to be sure that what I've drawn here kind of looks roughly feasible. So y equals to 2 to the power of x plus 2 minus 3. That's my equation. So my y-intercept I will get when x equals to 0. So I get y equals to 2 to the power of 0 plus 2 minus 3. And 0 plus 2 just gives me 2. So this is 2 squared, which is 4 minus 3, which equals to 1. So interestingly enough, I get another y-intercept at 1. That's kind of interesting. So if we just draw this whole thing out, this gives me something that looks like this here. Let's make this really thick and nice. But I get an exponential that has been shifted down 3 units and to the left 2 units. But that brings us to the end of this video. I know it was quite long, but we're just looking at all of the different ways, just making sure we've covered these different ways that we can transform our graphs. And we can do so by just applying the things we've already observed. So things like this, where we can already tell we have horizontal and vertical translations, and we can just work through transforming these graphs. But that brings us to the end of the video today. Thank you so much for watching, and I will see you next time.